This is Josh White with JW Math Tutoring. Today's video, I'm going to focus on 10 problems from the December 2024 Digital SAT Math Test. So let's go ahead and get to it.
But life is a dream that calculus could never predict.
Before I begin going through this third worksheet of December 2024 Digital SAT Math problems, just want to mention a couple things, and I mentioned this at the start of each of these videos. First, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, sign up for notifications. Second, make sure you check out parts 1 and 2 for the December 2024 test if you haven't done so already. And of course, check out the previous month problems as well. And then third, uh, these are all from problems that have been self-reported. So it's possible that there's more information, in the problem if you saw it, if you got this problem on your official test that you took. So just be aware of that. That's why if something's missing, that's why, because the information wasn't self-reported. And second, some of these problems are going to be done as free response, but on the test, they might actually have been multiple choice. So there could be alternate methods you could use to solve the problems if they are multiple choice, as compared to only being free response. So please keep that in mind as well. All right, with all that being said, let's go ahead and get started on problem number one that dealt with resistors in a circuit. So this circuit has 8 total resistors. I'm assuming it's a series circuit, not as compared to parallel. If you've taken physics, you would understand that. But if not, just completely ignore it. Because it tells you that the the total resistance is equal to the sum of the individual, basically, resistors, i.e. the resistance from each resistor. So there's a total resistance of 110 ohms. 3 of the resistors of the 8 have a total combined resistance of 70. So that means we've got 110 total. We take away the 70 for these 3. That means we have 40 total ohms left for 5 remaining resistors. So which of these inequalities represents, the possible values for the individual resistance of one of these 5 resistors? All right. The correct answer is going to be letter B here. First of all, the resistance for each of these individual resistors has to be positive, so it has to be, like basically the floor essentially is going to be 0. C doesn't even, make any sense because we only have 40 total ohms left to divide among 5, so it's impossible for even one of them to be more than 40, when that's all we have left. And obviously D is out because we only have 40 total ohms left, so it's impossible for any individual one to have a resistance greater than 40. And D has its upper limit or its ceiling, up at 110, anything from between 0 and 110. All right, so now if you're looking between A and B, basically there's nothing that says, that the maximum value for each remaining resistor is only 8 ohms. Or in other words, there's nothing that says that each one has to have the same amount of resistance. In other words, each like 8, 8, 8, 8, 8, or versus, 5, 5, 5, 5, 20. As long as they add up to 40 total ohms among the 5 resistors, then we would have a total resistance of 110 ohms, which meets the conditions of the problem. Okay, so anything between 0 and 40 is possible. Notice it's got to be strictly less than 40. It cannot be less than or equal to 40 because if one of them was 40, the rest would all have to be 0, and that cannot happen. But the correct answer for this one is just going to be letter B. All right, next up, number 2, we have a triangle. And I'm assuming this one you had to be given a picture just based on the description that you were given in the picture. So, or sorry, given in the problem. So basically you have an angle here, 53 degrees. The length of XE, okay, this is 19. This whole thing is 24. What is the area of triangle XYZ? So basically what they want you to do here is, of course, use the area formula for a triangle. Area equals 1/2 base times height. And we're just going to find this height value and then multiply that by 24, which is going to serve as the base, to give us our answer. So notice you can find the value for the height just by doing some basic trig. So if I just draw, this triangle on the left side separately, here we have 53, here we have 19 for the hypotenuse. The side that we want is h here, which is opposite the angle. So we want the opposite, we have the hypotenuse, so therefore we're going to use sine. Sine 53 equals opposite h over hypotenuse 19. Just make sure it's nice and clear, only 19. And now, so if we rearrange this, you multiply both sides by 19, you get the height is equal to 19 times sine 53. So now if you plug that in to the area formula, 19 sine 53 degrees, notice what happens. The 2 can cancel with the 24 and just make 12. So now we have whatever 12 times 19 times sine 53 is. So hopefully you recognize it's not going to be A or C. It's just going to be B or D. And you can just, if you don't know it, you can just multiply 12 by 9. Okay, it's 228. So the correct answer for this one is also going to be letter B, 228 times sine of 53 degrees. One other thing I do want to mention, technically, you could use the law of cosines here to solve for the area as well. And the way you would do that is basically you would use the law of cosines to find this third side right here, zy. And then once you get all three sides, what you would do is you would use Heron's formula, and you would go ahead and add up all the sides and plug everything into the formula and so on and so forth, and you would get some value, and then you would just confirm which of these answer choices that value is equal to, okay, which should be letter B. I'm not going to spend time going through that because if you haven't learned that, then there's no reason to bother doing it that way. But just an FYI, if you were stuck, if you're having difficulty, you could technically use like I said, law of cosines, because you're given two sides and an included angle, to find the third side, and then you could technically use Heron's formula from there. And one last thing also just to mention is notice, even though it looks like it, you're not told, at least from what I read online, that XZY is a right triangle. Okay, so you cannot assume that XZY here, you cannot assume that this angle up here, angle Z, is a right angle, unless they tell you that, or unless it was like marked in the diagram. But usually they would tell you that in the text, in addition to marking in the diagram. They wouldn't just mark it in the diagram but not say anything in the text. All right, bottom of the page, problem number 3. So this is a repeat problem. This is one we've seen before. I will show you both methods that you can use to solve it. So, excuse me. What you have here is basically a polynomial function, and you have some points. And what happens is when you plug in, let's say, this first point, so we have -1 minus 3 squared minus b, and then in the second thing, same thing, -1 minus 3 squared minus c. Okay. Notice what happens is -1 minus 3 becomes -4. -4 squared becomes 16. Okay. Now, let's say I wanted to plug in 7 for x. Okay, here, because it says, what's the value of f of 12 plus f of 7? So notice if you plug in 7 here, you get 7 minus 3 squared, okay, in both parentheses. What is 7 minus 3? Just 4. What is 4 squared? 16. You get the exact same answer, i.e. the same y value for f of -1 as you do for f of 7, because this polynomial happens to be symmetric. So in other words, the f of 7 value is just equal to the f of -1 value, which is 28. And the same thing is going to be true for -6 and +12. Because if you put in -6, notice it's going to be -6 minus 3 squared, -9 squared. Whereas if you put in 12, switch colors here, you get 12 minus 3 squared, which is +9 squared. They both give you 81. So the whole point is f of 12 will equal f of negative 6. So f of 12 will also equal 868. Therefore, you just add these two values together and you get 896, and that's the answer you fill in. And that's it. No more work is needed besides that. Now, you could also do this problem in Desmos. So here's how you would do it. What you do is you just go ahead, make a table, type in the 2 points. Even though we have 3 constants, we're actually going to be able to do a regression on this function with only 2 points. And the reason is because of the symmetry. So now I can just start filling everything in. Gonna need another parenthesis here. Minus b, close parenthesis, 2 open parentheses, x1 minus 3 squared minus c, close parenthesis. All right, so now okay, so now I went through, did a regression on the function. I have a nice graph of it. So basically, what you're going to see is, okay, when x is -1, it intersects function up here at 28. Okay, so now let's say we wanted to find what it's equal to at 7. Notice again, it's symmetric right here. F of 7 is 28. So you could just get it from that way, and then you could do the same thing with 12. Now the problem is, it's way up here. You got to zoom out, and then it's like kind of difficult to see where it intersects it at. You can find it eventually, but if you wanted to, you could also just retype the function like f of x equals a parentheses x minus 3 squared minus b, x minus 3 squared minus c. Okay, it's going to carry the a, b, and c values all over, and then you could just do f of 12 plus f of 7, 896, that's our answer. Okay, so that's how you could do this entire problem in Desmos. All right, top of the screen, top of the next page, actually here we have a problem that dealt with ants and specifically percentages. This is similar to the problem that was on the part 2 about the piece of land and like the percentage of buildings and all that kind of stuff on it. So essentially what you have here is you have 7,700 total ants, okay? And you have 10% which are queen, and then the remaining ants, which would be 90%, which are worker. Okay, and then of the worker ants, basically 60% are going to be female and 40% are going to be male. And we want to know what's the total number of female ants. So basically, that's just going to be the total number of female workers and the total number of queen ants. So we can just go through to Desmos. Let me get rid of all this. Okay, so first 7,700 times 0.1. Okay, that's my number of queen ants. I'm just going to call that Q. And then, okay, that's how many worker ants I have, 6,930. And then I'm going to take 60% of that, 60% of W. That is, I'm going to call that F. That's the number of female worker ants. So how many total female ants do I have? Well, I've got that, the F plus the Q. Slide this up. So together I should have 4,928. So the answer I get to this problem, 4928 for the total number of female ants. All right, the next question, number 5. This one is also a repeat question. It appeared way back in, I think it was in June is where I first saw it. But the easiest way deals with predators and prey, and they're both the same, but then they each increase by different amounts, and want to know what percent greater, or could also be percent less than, depending on how it's worded. One is versus the other after these increases, after these changes. So the way I would solve this is by picking numbers, and I would say, okay, we're going to start with 100 for each group. Okay, the prey increased by 2,000%. So 2,000% of 100 means you take 20, which is the decimal equivalent of 2000%, and you multiply it by 100, and then of course we add that to the starting value. So we started at 100, we're technically increasing by 2000, and then we are going to end up at 2100. That is for the prey. Now, for the predators, they're going to increase by 150%. So as a decimal, that's just 1.5. Multiply that by 100, add 100 to the original. This is just going to be 150. So we end up at 250 for the predators. Now, it's asking the number of prey is what percent greater than number of predators. So essentially, we're finding a percentage increase or a percentage change, so to speak. And the formula, new minus old over old, or new minus original over original, since we're saying prey is what percent greater than predators, that means I'm going to do 2100 minus 250 over 250. And then, of course, multiply it by 100% to turn it into a percentage. So this you could just go to Desmos and do and work it out. Just slide this down. Okay, so that's our decimal equivalent, but then, of course, we want to multiply by 100. So we get 740%. And we can just confirm that this is the correct answer, because if I had 250 as my starting value, I multiplied that by 7.4, and then I added that to 250, do I get 2100, the number of prey, as my ending value? In other words, is 2100 740% more than 250? And the answer is yes, it is. So that just confirms this correct answer. So what you would grid in, most likely, depending on how it's worded, is just the 740, and that's it. All right, we have another exponential form question here, slightly different than some of the ones that were on part 2, but it's still very similar in terms of its setup. So basically, what you have going on here is, this a, b, let's say to the s, would be equal to t. In other words, when you plug in s for x, the output you get, the y value, is equal to t. Then when you plug in s plus 1 for x, the output you get is t minus 0.55t. Now I'm just going to combine that into 0.45t. Basically, it's just 1t minus 0.55t equals 0.45t. So now, if you notice, if you take this first equation right here that's already solved for t, and you just plug it in here, okay, you get ab to the s plus 1 equals 0.45 times ab to the s. So a couple things. First of all, we can divide by the a and cancel them out. And you can also technically divide by b to the s on both sides. So on the right side, you get 0.45. On the left side, you have b to the s plus 1 over b to the s. Well, remember the rules of exponents. When you divide two terms, two technically polynomials here, you subtract the exponents. So it's s plus 1 minus s. So this whole thing just simplifies to b to the first. So what's the value of b? It's just 0.45, and that's it. So the correct answer for this is just 0.45. That's what you would fill in. Now, theoretically, you might be able to would probably be able to figure this out just by looking at it and realizing that since this is an exponential function, and you have a, b to the x, right? For every increase in x, say by 1 unit, you're going to multiply your y value by b. So it's like if you're starting with just t, and then you increase it by 1, and you end up with 0.45t, the only way to get there is to multiply it by 0.45, which is what the value of b is. So that's just kind of like the theoretical way to figure it out without having to go through all this algebra. So if you're able to recognize that, that's fine. That's perfect. That's great. You can just see that like the number you multiply by, which is b, the base here, just has to be 0.45. Now, I'll also just show you real quick how you could do this in Desmos as well. So what we can do is we can make a table, and I'm going to put s and t here, and here I'm going to put s plus 1, and here I'm going to put, you could just make it 0.45t, or you could type in the whole thing of t minus 0.55t if you want to do it that way. Now, I'm going to let s just equal 1, and I'm going to let t equal 3. Okay? So these values you can pick. There's nothing that says, like if s is 1 that t is 3, or t has to be 4, or if s is 2, t is 3, whatever. That doesn't, that part is not relevant. It doesn't matter. You can pick values for s and t just so long as, they're going to give you these 2 points here. Now we can go ahead and just do an exponential regression. So when we do this, the same form, notice right here it tells you that the value of b is 0.45. Now, if you change these values here, like if I change the s value, notice it adjusts the a value, but it does not change b, okay? And same thing over here. If I change the t to something different, changes the shape of the graph, it changes a, it does not change the b value. The b value is still 0.45, okay? So that's how you could do this entire problem in Desmos. Moving on to the top of the next page, problem number 7. Here you have a problem where you're given 2 cylinders that are similar. You're given the volume of each of them, and you're given the radius of one of them. And the question's asking for basically the difference in the surface area between the 2 cylinders. And notice it's framed as positive difference because it wants you to subtract the larger surface area minus the smaller one. Okay, so first thing I would do is I would take the volume of B and divide it by the volume of A. That will give us what I call the volume factor. All right, so if we do that, obviously the pi's cancel out, and you should get 27. All right, that means that the scale factor, let me just confirm here in Desmos. Yes, okay, so we get 27. So that's the volume factor. And the volume factor is the cube of the scale factor. Or an alternate way to think of that is the scale factor is the cube root of the volume factor. So the volume factor is 27. That means the scale factor, i.e. how much each individual side or, distance is for one versus the other is going to be 3. Cube root of 27 is just 3. So this means the radius of B is 3 times the radius of A. The height of B is 3 times the height of A. So we can use that to now figure out that I'm just going to put A and B here. Okay, and we'll put radius and height. So we know the radius of A is 9, that's given. Therefore, the radius of B is 3 times that, it's got to be 27. Okay, next we can figure out the height of cylinder A. So what we can do is we can take the volume, which is 567 pi, and set that equal to the formula for volume, which is pi r squared h, or pi r squared times the height. Fill in the radius value. Height value is what we're going to solve for. Okay, 9 squared is 81. The pi's will cancel out. Basically, you're dividing both sides by pi, and then just divide this by 81. You should get for your height 7. Let's just go to Desmos to check that. Okay, good. Height is 7. All right, so now I can just fill in my little chart here. That means the height for radius B is actually going to be 21. Now, we can calculate the surface area for cylinder A. So they give you the formula here. This is the surface area of a cylinder is not one of the provided formulas on the test. So just be aware. Not sure if it's provided in problems on the test because you don't have the official exams to look at. So I provided it here, but otherwise definitely make sure that you have it memorized. So we get 2 pi times 9 squared plus 2 pi times 9 times 7. So if we work that out, that should come out to 288 pi. Let's just go to Desmos to check it. Note, I'm going to skip just skip all the pi's. I just want the coefficient, the number in front of it. So I'm just going to leave the pi out, put everything else in. Okay, good. So surface area A is 288 pi. Now, you technically don't actually need to calculate the surface area of B. You actually don't even need to figure out the height of B either. A little shortcut that you can use to save time is that the area factor, which is related to the volume factor and the scale factor, okay, the area factor is just the square of the scale factor. So the scale factor is 3, therefore the area factor is going to be 9. So I can just tell you that the surface area of cylinder B is going to be 288 times 9. $25.92 pi. Now, if you didn't know that, or if you just want to calculate the surface area of cylinder B, completely on your own, like that's fine as well. So let's just go ahead and do that, just to confirm, that's what we get. So surface area B is going to be 2 pi times 27 squared plus 2 pi times 27 times 21. So I'll just go to Desmos again. All I have to do is replace the 9 with a 27 and the 7 with a 21. 2592, I get the same answer. Okay, just confirms that it is correct. All right. So again, that's just a little shortcut you could use if you want to save time, want to skip some work. Now we can do the final step. It's 2592 pi minus 288 pi. We don't care about the pi part. We're only cared about the subtracting the coefficients here. So we can go ahead and do that. 2304 pi is what you get for the positive difference in the surface area, but we only want the number in front of the pi. So 2304 is the answer you're going to fill in for this problem. Okay, next one up, question number 8. So what I'm going to do for this one, where you have a quadratic equation, basically they tell you it's factorable. That's what this whole px plus q thing is. And basically it's got the b value already filled in as 196. They want to know what's the largest possible value of AC. So the traditional way to do this, the by hand way to do this, is to take your discriminant, your b squared minus 4ac, set that greater than or equal to 0, and then plug in 196 for b. A and c, just put a and c in, and go ahead and solve this inequality. So what you end up doing is you just get 196 squared, 38,416, greater than or equal to 4ac, divide by 4. AC should be less than equal to 9604. So that should be your answer. Again, we'll just double check here. It's 196 squared, and then that value gets divided by 4. So we should get 9604 as the answer. Now, you could do this problem in Desmos, but I think it would be probably time prohibitive in that, basically you would enter the I guess not the full equation, but you would enter just the function, whatever set it equal to y, add some sliders. Now, you could set C to whatever, you could get, set A to whatever, and then down here you have like your AC value, right? So eventually what you're looking for is, and it's kind of difficult to see here, like eventually you want, I'm just gonna like jump these up here. There to be no X intercepts. So, okay, see right here, I'm at 9,500. And then if I go here, okay, see like right now I got my AC value 9,600, and see it's just below the x-axis. So the largest possible value is going to be the largest A and C values, such that you have at least one solution or one x-intercept. So like right here, 9610, it's already over. So it's something obviously less than 9610, but more than 9600. And then you could try this, 9601, 9602, 9603, 9604. Okay, notice right here it's on the axis, so there still is one solution. Okay, but now 9605 is too high. Basically, it's not a possible value of AC because there are no real solutions, which would mean that the expression's not factorable, which it is. So you could do this using sliders in Desmos, but because the numbers are so big, and you'd have to like constantly scroll and what I mean, like keep making them larger and larger, I probably would not recommend that way. I mean, you can absolutely use it to check and confirm that your answer is correct, which I just did, knowing it was 964 already. But if you're just trying to like, figure it out on your own, I probably would not recommend that method. All right. Question number 9, we have another repeat, but this one I'm also going to show a second method you can use to solve this problem that I did not show in my last video that had it. So basically what you have going on here is there's a right triangle inscribed in a circle, and the hypotenuse of the right triangle is a diameter of the circle. And then you draw an altitude to the hypotenuse of the right triangle. Okay, you know that the diameter, so from A to C here, the whole thing, is 125. And we know that BD, this part right here, is root 246. Okay, so first thing I'm going to show is, first method I'm going to show is the one I did not show the last time. This was in, I believe, one of the November problem videos. We want to find the ratio of CD to AD. Okay, the two parts of this diameter, basically. Excuse me. So what I'm going to do is I'm going to draw a line, okay, here from the center of the circle, let's just call it O, up to point B. And you could also do it down here to point E, doesn't matter. Okay, when I do that, what I end up making here is a right triangle, BDO. Okay, I know that this side BD is root 246. The hypotenuse is also a radius of the circle. Now, if AC is a diameter, that means the diameter of the circle is 125, which means the radius is half that. So it's 125 over 2. Now I'm going to use Pythagorean theorem to find DO, this other leg of this right triangle. And I'll explain why we do that in a second. All right, so the easiest way to do this is just do x1 squared plus square root 246. I mean, I could just write 246, but I'll just make it. There we go, square root 246 squared. And that's going to be equal to 125 over 2, that expression squared. Okay, so this side of the triangle right here, you can see it was equal to 60.5. So we can just leave it as a decimal for right now. That's fine. Okay, so this little part right here is 60.5. How that helps us is because now I can find the length of AD. Okay, because I know that from A to O, which is a radius, is 125 over 2. So to get AD, I just subtract DO minus AD. Excuse me, said that backwards. To get AD, I'm going to subtract AO, which is a radius, minus DO. So AO is the radius. That's 125 over 2. And I'm just going to do this again, all in Desmos. DO, we just found 60.5. So 125 over 2 minus 60.5. That means the length of AD is just equal to 2. Notice this also means that I can find the length of CD just by adding these two parts together. In other words, CD is just going to be 1 radius plus 60.5. So in other words, CD is going to be 125 over 2 plus 60.5. I go to Desmos. I just add those two together. I get that value. 125 over 2 plus 60.5. That number is 123. Okay, so this whole part's 123. So what is the ratio of CD to AD? Well, 123, which is CD. AD, 2. So there's your answer, 123 over 2. Or you could also put in the decimal equivalent form of 61.5. All right, so again, that is another method you could use. That is not the traditional method. It's not the method I used when I first explained this, back in the November problem set. So let me see here. Let me just show you an alternate way to figure this problem out. All right, so just quickly redo the picture. Here's our right triangle. Here's D, here's E. Okay. Root 246. See, whole thing 125. Okay, so what we're going to do is I'm going to just set this equal to x and this part from D to C equal to 125 minus x. Then there is a theorem in geometry which basically says if you have a right triangle and you draw an altitude from the right angle to the hypotenuse, okay, that altitude that you draw, which in this problem is the 246, this is the altitude, is the geometric mean between the two parts of the hypotenuse it splits. What that means is you basically set up a proportion where you put the side or the value that's the geometric mean like opposite each other. You could technically go top left bottom right, or technically bottom left top right, it doesn't matter. And then the other two spots you fill in with, in this case, the two things it's the geometric mean between. Okay, so here we have a proportion that we now just cross multiply. So root 246, root 246, that's just 246, going like this. And then the other way, 125x minus x squared. Now I'm going to move everything over to the left to make it x squared minus 125x plus 246 equals 0. Now you could go ahead and solve this. You could just go to Desmos and graph it and look for the 2x intercepts. You could, just factor it. It's going to be minus 123 and minus 2. So x equals 2 or 123. Excuse me. So we know the two sides are going to be, one of them is going to be 2, the other is going to be 123. But the question is which is which, because it specifically wants CD over AD. So what goes on top, the 123 or the 2? Because of this information right here in the problem, BC, i.e. this side, larger than AB, i.e. this side, that's what makes CD the larger side or the larger value. So that's what confirms that the answer is with the 123 on top and a 2 on the bottom. Okay, so notice we get the same exact answer using this method. Basically, it's using the idea of a geometric mean, but the geometric mean, like this formula, this theorem, really comes from matching up the corresponding parts of similar triangles. That's essentially what you're doing. So let's move on now to the very last problem, number 10, top of the last page. This is a repeat problem. This is actually basically a carbon copy of one of the problems from the Blue Book practice tests. But still going to go through it because people reported on the test and show you how to do it. So you have 3 points given for this rational function, which is basically made up of a linear function on top over x plus 3, another linear function on the bottom. They want to know what the y-coordinate of the linear function, the f of x that's in the numerator, is. So there's two ways you could do this. You could do this by hand, of course, or you could do this just straight in Desmos. I'm going to go to Desmos first and just show you that, and then we'll just do it by hand just to confirm. So we go to Desmos and we enter a table, but there's one thing that you have to notice, and that is if you rearrange this function, it turns into g of x times x plus 3 is equal to f of x. So in other words, that means for any x value that you plug in, the f of x value, i.e. the y value for the f function, is going to be the g of x value here times the x value plus 3. Okay, so in other words, for negative 27, you're then going to take the g of x value, which is 3, and multiply it by negative 27 plus 3, i.e. by negative 24, and you get negative 72. Same thing for the negative 9, 0. It's going to be 0 times, well, technically it doesn't matter. It's negative 9 plus 3, but 0 times anything is just 0. And similarly, for 21, you have 5, the g of x value, times 21 plus 3. Okay, 21 plus 3 is 24. 5 times 24 is 120. So now I have 3 points that are in the function f of x. These x values paired with these y values. So now we just go to Desmos and we just are going to do, actually I just realized you don't even need to do this for the Desmos version. This is actually what you have to do if you're going to do it by hand. So whatever, we'll skip that, we'll leave it. You don't even actually have to do that for the Desmos version. I just realized that we can just go straight here. We can just type in the points we're given. I'll come back to those later. And then we're going to do a regression. And the regression is going to be of a linear function divided by x plus 3. Okay, so now that I do that, notice it returns your values for m and b, okay, for my linear function. It wants the y-coordinate of the y-intercept of that. Well, that's just b. So right here, answer's just 36. So again, if you do it entirely in Desmos, you do not need to figure out these points. You can just take the chart, the table, the 3 points that are given, and you can just go straight here into Desmos, type them in, do a linear regression, and get the answer that way. Okay, that's the quickest, easiest way to do it. Now, if you didn't know you could do that, didn't want to do it in Desmos, you want to do it by hand, okay, you can calculate the 3 points on f of x just like I did. Now, at this point, you technically could go to Desmos, do a table, and just do a basic linear regression, meaning y1 tilde mx1 plus b, and get it that way. But I'll just, go ahead and do it by hand since I already have the points here. So I'm going to do 120 minus 0, and then 21 minus negative 9. So the slope becomes 120 over 30, which is just 4. Now we need to find b. So I'm going to take one of the points. I'm going to pick this point. And I'm going to say, okay, 0 or y equals m, 4, times x, negative 9, plus b. 0 equals negative 36 plus b. B equals 36. So this is how you could work the problem out by hand, but you do need, if you're going to do it this way, you do need to notice or recognize that when you multiply both sides by x plus 3, that's how you solve it to get the y values for the function, f of x that correspond to the given x values. All right, I hope you enjoyed this video, December 2024 Digital SAT Math Problems, Part 3. If you haven't done so already, please do check out Part 1 and the video for Part 2. If you have any comments, questions, alternate solution methods, feel free to leave them below in the comments. If you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, I will be back soon. I'm working on putting together a Desmos guide for the digital SAT math section, so look out for that in the future.